All right, this is going to be P5, part 4 on the quadratic formula. All right, so with this is the quadratic formula. All right, and it seems big and scary, but it just came from completing the square. So if you complete the square with variables instead of numbers, you end up deriving this formula. So I'll give you a second. You might want to write this down on a separate sheet of paper so you can reference it as we do these problems. All right, so here, using the quadratic formula, all we have to do here is identify A, B, and C. Now, A is 3, all right, because I'm going to be looking at that and comparing it to this. B is -6, and now I notice, hey, this one's equal to 0 up top, and this one's not. So what I have to do is I have to get this equal to 0. So I do 3x squared minus 6x, and how do I move that 5? Well, I subtract it to give me that. Now they look identical, and I can find C is -5. All right, it's really important to make sure that this is equal to 0. If it's not, we run into problems, and we'll get the wrong answer because our values will have switched signs. So it needs to be equal to 0. All right, so now all we do, if we memorize that formula, is plug it in. So we have x equals -6, because that's B, plus or minus the square root of -6 squared minus 4 times A. Well, A was 3 and B was -5. All over 2 times 3. Now we go ahead and we can start simplifying this. So we have x equals 6 plus or minus the square root of 36. -4 times -5 is 20. Times 3 is 60 over 6. So I'll have x equals 6 plus or minus the square root of 96 over 6. And I have to simplify that. So what goes into 96? So we have to break down 96. And since I'm running out of room because there's a graph here, 2 and 48. 48 is going to be 16 and 3, and 16 is 4 and 4. So I will get x equals 6 plus or minus 4 root 6 all over 6. And then of course I have to simplify that out, and I get x equals, I'll get x equals 1 plus or minus 2 root 6 over 3. If you're wondering how I got that, I did 6 plus 4 root 6 over 6, and then I did the same thing for the minus. So, and that gave me 1 plus or minus 2 root 6 over 3. All right, now we can go over here. Let's look at the graph. All right, if I were to type these into my calculator, all right, 1 plus 2 root 6 over 3, that would be this root, and 1 minus 2 root 6 over 3 would be this root. All right, so let's go ahead and do this one. Let's identify A, B, and C, but first let's check out to see if it's equal to 0, and it is. So A is 1, because it's understood there's a 1 there. B is 8, and C is -2. So we're going to go ahead and we're going to write x equals -b plus or minus the square root of b squared minus 4 times 1 times negative 2 all over 2 times 1. Again, I'm just plugging it into that formula right there. So that's why it's important to have this written down so I can reference it. So now I have x equals negative 8 plus or minus the square root of 64 plus 8 all over 2. Now 64 plus 8, that's 72. And I know 72 is broken down into 6 root 2. So this will be x equals negative 8 over 2 plus 6 root 2 over 2. And x equals negative 8 over 2 minus 6 root 2 over 2. So my final two answers would be x equals negative 4 plus 3 root 2 and x equals negative 4 minus 3 root 2. So the hardest part about this is going to be the last step where we're breaking it down and we are dealing with roots. All right, so let's look at number 1. So number 1 here, A is 2, B is negative 3, and C equals 1. And I'm good to go because it's equal to 0. So I have x equals negative 3, because remember it's negative b, plus or minus the square root of negative 3 squared minus 4 times a was 2 and c was 1 all over 2 times 2. So x equals 3 plus or minus the square root of 9 minus 8 all over 4. Well, that will be x equals 3 plus or minus the square root of 1 over 4. Well, we all know the square root of 1 is 1, so we have x equals 3 plus 1. Well, that's 4, and 4 over 4 is 1. And we'll have 3 minus 1, which is 2 over 4, and that's 1/2. Okay. And now here, okay, what do I do? Well, I have to get it equal to 0. All right, now, with this, it says use the quadratic formula, but I'm not sure that's the best way to do it because I have roots and I only have one x here. So let's see what happens. So we have a, we have a b, and we have a c. So we have to move this over to get x squared minus 5 minus root 3. So this piece here, this is going to be my c. So we have 1 for a, 0 for b, and c will be negative 5 minus root 3. So we have x equals negative 0 plus or minus 0 squared minus 4 times 1 times negative 5 minus root 3 all over 2 times 1. Well, the 0 out in front is not going to make much of a difference, so we just have plus or minus the square root of 0 plus 20, because I'm going to distribute this out. plus 4 root 3 all over 2. Well, 0 plus anything is that thing, so we have plus or minus the square root of 20 plus 4 root 3 over 2. Now I can factor a 4 out of this. So it now looks like this. Well, here's the thing. The square root of 4 is 2. So this 4 comes out front because the square root of 4 is 2. So that 4 becomes that 2. And it's all over 2. And 2 divided by 2 is 1. So this is just plus or minus the square root of 5 plus root 3. All right. Now solving equations algebraically, we can factor. We can extract square roots, complete the square, and we can use the quadratic formula. These are all the ways we can do it. We can also approximate using our functions on the calculator. So here, what we're going to do is we go to y equals, and we are going to type in, all right, x cubed minus x minus 1. And then what we do is we don't hit graph, we hit second and trace to go to calculate. So second, and I believe it's trace, because we want calculate, which should be written in blue above that. And then we're going to go down to the one where it says zeros. All right. So we're looking for zeros. Maybe it says roots. Maybe it says x-intercept. But that's what we're looking for, is the 0 or the root or the x-intercept. And then it's going to ask you on your calculator, once you hit enter, to pick a bound to the left. So pick a point to the left. So if I'm looking at this graph right here, I'm going to pick a point right here because it's to the left of my intercept. And then it's going to say pick a point to the right. And I might pick that point right there. And then it says guess. And when it says guess, that's when I want to try and find a point that's as close to that intercept as possible. And what it does is it spits out an answer for you at the bottom of your screen, just like it says here, and that is your intercept. We're going to approximate it. Okay, we can also use the table feature at times. Sometimes it's helpful. Okay, so if we use that table feature, okay, here we're looking for where the y is 0. So we're looking for 0. Okay, and a lot of times we're not going to get it. Okay, but as I can see here, all right, notice we go from a negative to a positive. So that means my answer is somewhere between 1.3 and 1.4. So I might say it's 1.32. All right, because I'm looking for that sign change between negative and positive, because that's going to indicate a root, where my graph goes from below the x-axis to above the x-axis. Here, same thing, all right? Might be even the same problem. Notice here, all right? Let's see, it is the same problem. Notice when I said, oh, I think it's 1.32, I'm pretty close, but notice it's in between there. So I might say, okay, I'm gonna go back to the drawing board. Maybe it's 1.325. Okay, and then we go over here and we can see, oh, Mr. Harmon was really close. Notice there's my sign change. And now I'm like, all right, maybe it's gotta be in between that. Maybe it's 1.3245. All right, but that's how we can use our tables to help us. All right, now what I need you guys to do is I need you to work on this section here while I'm gone. All right, see ya.